This video will cover installing the Arduino support package and the additional library after MATLAB and Simulink have already been installed. First, you'll want to open MATLAB in administrator mode by right-clicking the icon wherever your icon is, or any of the other subsequent icons. Right-click and then run as administrator. Once MATLAB has opened, you will click on the add-ons icon. Filter products by MathWorks. You should see Simulink support package for Arduino. If you don't see that, you can filter it further by typing Arduino and then finding Simulink support package for Arduino hardware. Click that, click install, and then follow all of the resulting prompts to install the software. Click accept, and then install all of the suggested products. If you have a device, you can click Setup Now. If you don't, just click Setup Later. Now we've installed the Simulink support package. We can always go back to that setup by clicking Add-ons, going to Manage Add-ons, clicking on the gear icon for the Simulink support package, and then follow the steps once you have your device plugged in. To install the additional library, click Add-ons. In the search bar, type RASPLib, R-A-S-P-L-I-B, RASPLib. Select Rensselaer Arduino Support Package Library, click Add to MATLAB, and then the library is installed. You can see where it's installed by clicking on the Open folder, and it will show you all the contents of that library. Click back to bring us to the Documents MATLAB folder. And in your Documents MATLAB folder, we want to create a new folder that it's going to use to create all the compilation or keep all the compilation files. So go to New Folder. I like to call it Compile, and I usually put whatever version of MATLAB I'm using. In this case, it's 2020B. And I want to specify all of the files, the temporary files that it needs to compile stuff to be in this folder. So we can click on this, and this is where it's going to put all of those compiled files. So we can copy this path, then go to Preferences, Simulink, open Simulink Preferences, and then click on the General tab. The cache folder is going to be that folder we created, and the code generation folder is going to be that folder we created. That way, when it creates all these additional files that won't have any meaning to us, it'll do it in that folder. To test the library in your hardware, you'll want to plug your hardware in. Verify your hardware is connected by going to the Device Manager. Press the Windows key, type in Device to open the Device Manager. And then I can see my device is plugged into COM port 3. And then I want to open the demo to test and run on the hardware. So we can click on the drop-down box for Manage Add-ons. We want to go to the Rensselaer Arduino Support Package Library, open the folder where that was installed, because that has our examples in it. Go into the examples folder, and you want to find the demo for your system. In this case, this system is a MinSeg Mega, so we want to go to Demo, MinSeg Mega, the latest version, V4, and you could open and run this, but we're going to so we have a file we can always use to get any of the blocks we need. we're going to copy this to our MATLAB folder. Our Documents MATLAB folder, I'm going to put this file in here, and then I'm just going to rename it whatever demo file, whatever name you would like, but then you can use this as a place to start all of your projects. So we can open this demo file. And when you open the demo file, it will have all of the blocks that are used to interface with your hardware. First, we want to verify that it will be able to download to the right area. So you can go to, first make sure you're in the Hardware tab, and then you can click on the Hardware Settings, which you can also access by right-clicking anywhere in the Simulink diagram and going to Model Configuration Parameters. That's the same menu. If we go to the Configuration Parameters, the Hardware Implementation window, and then click the Target Hardware Resources, go to the Host Board Connection, and then you can see where you would specify the COM port. If you have an Arduino Mega, you can use automatically. Some systems, you have to specify this manually, so that's what we'll do. We'll specify this manually, go to our COM port, it was COM port 3. Now that I know that it's going to download the right location, again, make sure you're on the Hardware tab. Click on Run on Hardware and push this Monitor and Tune button. It will then compile this code, download this code to the device, and once it's downloaded to the device, it will connect to the device, read all of these different sensors, and if there's other things connected, like motors, it will, in this case, apply a sine wave of 0 to 4.9 volts to each of the motor connectors. So it will run all of the hardware, which will allow you to test and make sure everything is working. Right now it's compiling all of the files. If I go over here and look inside of our compile folder, you'll see it's creating a bunch of files it needs to compile the code before it downloads it. These don't have any meaning to us, and that's why it's nice that we have a folder to keep all of these meaningless files in, instead of creating a bunch of files potentially all over our computer. You can click on this View Diagnostics tab to see what it's doing. In this case, it's still compiling the files. Usually the first time it builds a model, it can take some time to create all of the files it needs, and then subsequent times it's usually a little faster. Here we can see that it has compiled. We can see how much memory it's using on the device. Then we can see that it's going to be downloading and connecting to the device. If you had the device in front of you, you should be able to see some flashing lights as it downloads the code. After it's downloaded it, then it's going to attempt to connect to the device, and then it will run this software on the device. So in this case, it's reading the magnetometer, the gyroscope accelerometer, and we can see that the motors are moving back and forth. This allows me to verify all of the hardware is working. We went over installing the Simulink support package, installing the additional Rensselaer Arduino support package library, creating a folder that in your Documents MATLAB folder, that all the compilation files will be kept. Then we copied an example file to our Documents MATLAB folder. We ran this demo file in the hardware to verify that all of our hardware works. And now we're ready to perform any labs. And we can use this demo file whenever we want to start a new project or a new lab, because it has all of the blocks used to interact with the hardware system. We can open up this file and save it as a new lab, lab 1. And then if we need to read some encoders and maybe the gyroscope then we can delete all of the other blocks that we don't need. Maybe we're just using one motor. And then this will allow us to quickly get started on any project or lab using the blocks we need and then adding any other logic or code that we want to the system.